Algebra 2. I'm going to be covering Lesson 55, which is on probability. And so it actually covers two things, the probability of something happening and the odds in favor of something happening. So I wanted to go over both. In this first part, when you see this capital P, that stands for probability. So the probability of any event equals, it's going to be a fraction. So on the top, it's the number of favorable outcomes, what you want or what you're discussing happening, out of the total of all possible outcomes. Odds in favor is slightly different in that it's the favorable over unfavorable. So the bottom is not the total. The top in both of these should be the same. It's the bottom that is different. In probability, we look at the total. In odds, we look at what we want out of what we don't want. And so the bottom is slightly different. So I'm going to show you a real example so you can see the difference between both. So if I have a cube, also known as dice or whatever, I have numbers 1 through 6 on my dice, right? When you roll a die, die is dice. Wait, die is singular. Dice is plural, sorry. You have numbers 1 through 6. So I'm going to show you the difference. If I say the probability of rolling a 6. So on my dice, I have numbers 1, 2, 3, 4, 5, 6. So the probability that if I roll the die and it lands on a 6, there is only one 6. Okay, so this number here, only one number, 6. The bottom number out of probability should be the total numbers on the dice. So there's 1, 2, 3, 4, 5, 6. So this bottom number is total numbers. Okay, so the probability of rolling a 6 is 1 out of 6. Now I want to show you the difference. Odds in favor of a 6. There is one 6, so notice the top number is the same. But on the bottom should be how many numbers are not a 6. So on the bottom, I'm looking at numbers 1, 2, 3, 4, 5. There are 5 numbers that are not a 6. This is also written as 1, 2, 5. So let's go over the difference. So on the top, this is still only one number 6. On the bottom are numbers that are not a 6. And so that you can see the difference. So probability is what I want out of all total possibilities. Odds in favor is what I want, so there's only one 6, over how many are not a 6. And so odds would be 1 to 5. You have a 1 to 5 shot of getting a 6. Probability is 1/6, or a lot of times probability is written as a percent. So 1/6, I don't know, have that memorized. 1 divided by 6. I have about, 16.7% chance of getting a 6 when I roll a die. Okay, so we're going to jump into our lesson practice, which is page 395, and practice some probability and odds in favor. So part A, I have the book right here. A calculator program to generate random numbers from 1 to 10. So I'm going to go ahead and list that. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's asking what's the probability if a number is randomly selected that it's a perfect square. Now perfect squares are, literally think of a perfect square. A perfect square would be like a 2 by 2 or a 3 by 3, right? Or 1 by 1. You can literally think of it that way. But the answer, a perfect square, would be the area. So I'm looking at the numbers 1, 4, 9. So 1 is a perfect square, 4, 9, right? 16 is a perfect square. That would be a 4 by 4, which has an area of 16. But, and I could keep going, but we're only looking at numbers 1 through 10. So I only have 1, 2, 3. So that represents there are 3 perfect squares. Out of, there are 10 total, whoops, that's not how you spell total. My bad. 10 total numbers. So my probability is 3/10, or if you divide, that's 30%. And sometimes they'll ask for a percent, sometimes a fraction. You could also write it as a decimal, 0.3. So there's all kinds of ways to write your answer. So I'm trying to take good notes for those of you who look at these, so hopefully it helps. So B is involving geometry, and it's very similar to a one on a test, so please pay attention. So they've given us a rectangle that is 4 inches by 7 inches, and they've given us a region where a triangle has been cut out, and they said this is 5 inches. And they are asking, what is the probability that a point randomly chosen is in the shaded region? So the way we're going to calculate this is we need to find the area of the shaded region over the area of entire shape. So hopefully we can agree that the entire shape, oh, and I'm sorry, in the book, this is the area that is shaded, okay? So I hope you can see I'm looking for the area of this irregular shape. Actually, if you cover that up, that's a trapezoid. So I'm looking for the area of the trapezoid, but a triangle has been cut off. And so I am going to have to subtract out that triangle. So I should be setting it up like this. Probability will equal, the top should be the rectangle minus the triangle, and the bottom should be the area of the rectangle. So I've got the rectangle is 28 minus, and I'm going to have to subtract the area of the triangle out of 28, right? 4 times 7. So this triangle, let's see here. I know the triangle has a height of 4 and a hypotenuse of 5. So I could find this, right, by using the Pythagorean theorem. 25 equals a squared plus 16. So if I subtract 16, I get a is 3. So the area of my triangle would be 3 times 4 divided by 2. Right? Base times height divided by 2. So that gives me 28 minus 6 over 28, which is 22 over 28. I do expect you to reduce, so my probability is 11 out of 14, or if you wanted a percent, 11 divided by 14 is, sorry, that's a glare, is almost 79, so I would just say 78.6%. So that's the probability. And think of it this way, if I threw a dart at this shape, the probability that I'd land in the shaded region, since it's the majority, is over 78%. Okay. There is going to be one like that. So it's the area of your whatever region divided by the area of the total shape. So moving on, and I'm going to write on the back, and hopefully this scans well if I write it on the back. We'll see, right, if this scans well. I'm going to take a little sip of coffee. Please don't be mad. And I guess I would never know if you were mad, right? Because you're not here. Okay, so moving on to part C. It says 5 of 7 athletes are carrying athletes of varying heights will be chosen for a photo. If their positions are randomly chosen, what's the probability they are lined up from shortest to tallest, left to right? Ooh, this one really, 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 really hard. Okay. So, in fact, I think I have the answer in my book wrong. I do. Okay. So I have 7, and I'm choosing to line up 5 of them. So this is actually a permutation. And if I enter that in my calculator, I get 2,520 ways that I can line them up. The probability that they're shortest to tallest would be 1 out of 2,520. I know it's extremely hard, and there's not one like that on your test, so I will do this for you for homework purposes, but it's not going to be happen on a test. Part D, if a teacher has 6 papers to grade and she randomly chooses 4 papers to grade, then this one, in this case, the order does matter because she is choosing the 4 students who usually score the highest. So she has 6 students, I'm choosing 4 of them. So that is 15. The chance that they are the highest, 4 highest scores would be 1 out of 15. I know those are crazy. But let's go back to probability. A calculator is programmed to the numbers from 1 to 100. If the enter button is pressed twice, what's the probability of getting a number less than 10 and a number greater than 50? So this is fun. And means I'm going to multiply. Okay, so and means you will multiply, or means that you would add. So that is an important piece of information. So let's do the probability it's a number less than 10. Well, the numbers less than 10 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would have 9 out of 100, right? Because there's 100 numbers to choose from. Numbers greater than 50, that would be 51 through 100. And so that's 50 over 100. So I have 9 out of 100 that can't be reduced times this one. 50 over 100 can be reduced to 1/2. So I get 9 over 200. Or if you divide, that's 4.5%. So it's small odds that I'll get a number less than 10 on the first try and a number greater than 50 on the second try. So this is not in the book. So if I said, what's the probability of getting even, right, an even number, it would just be out of 100, it'd be 50 out of 100, which would be 1/2, right? Half of them are odd, half of them are even, okay? But when you have 2 events, we're multiplying. So if I said, and I'm going to make the list smaller. Numbers 1 through 20, what's the probability that it's a multiple of 5 or, because we're going to do more probability later. I have to think of something. Or, oh no, I'll just keep it at multiple of 5 because I don't want to get into the next section. What's the probability it's a multiple of 5? Well, in 1 through 20, that would be numbers 5, 10, 15, 20. So there are 4 out of 20, or 1/5. Okay, so just some more probability practice. All right, I believe the next section is about odds. F, a bag of 15 red marbles, so 15 red, and I have 10 blue. What's the probability of picking a blue marble, keeping it out of the bag, and then picking another blue? Okay, so let's first talk about total marbles, right? I have a total of 25. I believe these were marbles, right? Sorry, I'm reading in the dark. Yes, these are 25 total marbles. So the probability of the first one is blue, is there are 10 out of 25, and means I'm going to multiply. Another blue. Now, I kept first blue out of bag. So are there 10 blues on and still in the bag? No, now there's only 9 blues because I kept the first one. Okay? And that also decreases my total. Now there's only 24. So that is why that second fraction changes. Okay? So now I'm going to reduce these. 10 out of 25 is 2 over 5. It makes it easier to multiply reduced fractions. And 9 over 24 would be 3 over 8. And so now I have 6 out of 40 or 3 out of 20. Lots of those on tests and stuff. So hopefully you have that. G. What are the odds of rolling a 6 on a number cube? Oh, we already did this. So I'm going to change it. Odds of a 4 on a cube. So there's one number 4, right? 1, 2, 3, 4, 5, 6. There's 1, 4. And there are 1, 2, 3, 4, 5 that are not a 4. So remember, odds is what you want. And all the numbers that are not a 4. And so my answer would be 1 to 5, or sometimes they use a colon. I think we only have a few more. So H. What is the probability? Oh, wait, sorry. The probability of an event equals 10%. What are the odds in favor? Okay, so 10% would be 1 out of 10. Okay? So odds in favor, remember the top number is the same, but this should be all the items you don't want. And so, or this can be written as 10 out of 100. So odds in favor would be 1 out of 9 or 10 out of 90, because it would be 10 minus the 1. And so if there was 2 up here, this would be 8. So like if probability of an event was 2 out of 10, the odds would be 2 out of 8. It'd be 10 minus whatever the top number is, okay? So it should be the bottom minus the top. Last one, they've given us a table, right? Wins and losses, and it asks us to do experimental probability for each one. And it shows us how to do this on page 394, but it has wins, losses, overtime. And it told us there were 53 wins, there were 22 losses, and there were 7 in overtime. So I have a total of 82. So I'm going to calculate the probability of each. This first one would be 53 out of 82, right? There are 53 wins out of 82 games, so 53 divided by 82. So this is 64.6%. The next would be 22 out of the total. How many did they lose? And this is 26.8%. And how many went into overtime? So 7 divided by 82, and that's only 8.5%. So that is how you would calculate experimental probability. So hopefully that gave you a taste of each kind. For homework, you are going to skip numbers 8, 11, 15, 21, 22, and 25.